We are in the middle of a full-blown AI gold rush. I mean, companies are throwing unimaginable amounts of money at this. But here's the catch. This whole digital revolution, it's built on a physical foundation, on silicon. And that foundation is starting to show some serious cracks. We're facing a critical shortage of the advanced chips that make it all possible. So how can that be when the money is flowing like never before? Today, we're going to dig into the very real, physical bottlenecks that are threatening to put the brakes on the future.
All right, here's our game plan for this deep dive. First up, we're going to get a handle on the absolutely insane demand created by this AI gold rush. Then, we'll put on our detective hats and diagnose the exact choke points in the supply chain. After that, we'll see how this scarcity is creating a brutal, zero-sum game. And finally, we'll try to understand what all this means for us in what's being called a new extractive era of technology.
So let's start with the scale of this demand because it's hard to overstate. This isn't just some hot trend, it's a tidal wave. The need for AI compute power is growing so fast, so vertically, that it's completely rewriting the financial playbooks of the biggest companies on the planet.
Okay, just look at that chart on the left. That curve for AI demand isn't even a curve anymore. It's basically a vertical line. And to have any hope of meeting it, the tech giants, the Googles, Amazons, and Microsofts of the world, they're just opening the fire hoses of cash. Check out Google's planned spending for 2026. It is nearly doubled. We are talking about hundreds of billions of dollars getting thrown at this one single problem.
And where is all that money going? Well, right here. It's going to these specialized AI chips, these accelerators. The market for them is just set to explode. We're looking at a jump from about $53 billion to over $280 billion in just 4 years. The hunger for these things is, for all intents and purposes, completely bottomless.
Which brings us right to the heart of the puzzle, doesn't it? With this much money, with this much investment flooding the system, why can't we just, make more? Why on earth are we staring down the barrel of a critical silicon shortage?
To solve that puzzle, we have to step away from the spreadsheets and get our hands dirty in the physical world of manufacturing. We need to find the precise points in the supply chain where the whole system is just breaking down under the incredible strain.
And this diagnostic chart is really, really interesting because it narrows down our search immediately. You see, the problem isn't really in the final packaging of the chips. The real emergencies, the critical constraints, are in two specific areas: logic, the brains of the operation, and memory, specifically the high bandwidth memory that fuels those brains.
So let's tackle that first choke point, logic. For the kind of AI everyone wants to build, performance is everything. And that means everyone is desperate for the absolute best, the most cutting-edge manufacturing process available. Right now, that's TSMC's 3-nanometer process, what they call N3. You can think of it as the most advanced, most sought-after factory floor in the entire world.
In this slide right here, this perfectly illustrates the massive traffic jam that's coming. Just look at the roadmap for 2026. You've got NVIDIA, AMD, Google, Amazon, Meta. Literally every major player is planning to move their most important, most advanced products onto that single TSMC N3 process at the exact same time. The entire industry is trying to cram itself through one very, very narrow doorway.
And this gets to the fundamental mismatch. You can change a budget in a few weeks, right? But you can't just wish a multi-billion-dollar semiconductor factory into existence. That process takes years of concrete, steel, and mind-bogglingly complex engineering. So we're bottlenecked by the speed of concrete, not the speed of money. Until those new factories come online, the supply is just physically capped.
Okay, now for the second choke point, and this one is all about memory. See, these powerful AI chips are useless if they're starved of data. They need a special kind of high-octane fuel called high bandwidth memory, or HBM. But this amazing high-performance solution creates a brand new and very physical problem.
So, unlike the standard memory in your laptop, which is small and pretty efficient to make, HBM is a beast. It's physically huge. To get its incredible speeds, it's stacked vertically, like a tiny skyscraper, and this design takes up 3 to 4 times more of that precious space on a silicon wafer. So every time a factory decides to make one HBM chip, they're giving up the space they could have used to make a whole bunch of standard memory chips.
And this visual just drives the point home. I mean, the difference in scale here is just striking. You can see the tiny little footprint of a standard DRAM chip compared to that towering stack of a future HBM module. This isn't just a small upgrade, it's a radical shift in physical size that is structurally creating a global memory shortage.
So let's recap. We've got two hard physical limits.
There's only so much advanced logic capacity at TSMC, and there's only so much wafer space for memory. And when you have basically infinite demand slamming into a fixed supply, well, you don't have a market of abundance anymore. You have a zero-sum game.
In this new reality, TSMC holds all the cards. They effectively become the kingmaker. With limited factory capacity, they just can't make everyone happy, so they have to pick winners. And as you can see, they're prioritizing the high-growth, super profitable AI customers like NVIDIA and Google. And that leaves the traditional giants of the consumer world, like Apple and Qualcomm, basically waiting in line.
Now let's watch this power shift play out in real time. Here in 2025, you can see that AI is already a massive customer for TSMC's advanced N3 wafers. But, and this is key, notice that the consumer market, our smartphones and PCs, still holds the majority share. For now, things are in a, let's call it, a fragile balance.
Okay, now let's jump forward just one single year to 2026. Whoa. The AI slice of the pie has absolutely exploded. It has swallowed up more than half of the entire N3 capacity. The balance of power has decisively shifted. The great squeeze on consumer devices has officially begun. And by 2027, it's game over. The takeover is complete. AI demand is projected to consume a staggering 86% of TSMC's most advanced logic chips. At this point, it's not just squeezing the smartphone and PC market anymore, it is effectively cannibalizing it.
Now, you might be thinking, hey, what if smartphone sales crash? Wouldn't that free up some supply? Well, this slide shows why that's really just wishful thinking. The memory demand from a single AI server is so enormous, so out of scale, that even a catastrophic 50% collapse in phone sales would only free up a measly 14% of the memory needed. It is, quite literally, a drop in the ocean.
So when you put all of this evidence together, the logic bottleneck, the memory space problem, the zero-sum allocation, it all points to one pretty sobering conclusion. We are entering a fundamentally new phase for the entire tech industry. An era that's not defined by limitless growth, but by extraction.
This quote from the source material just perfectly nails this new reality. For decades, tech growth felt additive. New things came along, but they didn't really destroy the old ones. The PC didn't kill the radio, the smartphone didn't kill the PC. But that era, it seems, is now over.
Here are the hard numbers laid bare. By 2027, AI is projected to eat up 86% of the world's most advanced logic and over 2/3 of all high-performance memory. And because of the hard physics we've talked about, factories take years to build, and AI memory is 4 times bigger, the math is just brutal. The only way for AI to keep growing at this pace is to systematically cannibalize the supply chain that used to be dedicated to our PCs and smartphones. This means your next phone upgrade might not actually feel like much of an upgrade at all.
So, if there's one key takeaway, it's this. We are no longer in a world where a rising tide lifts all boats. The AI revolution is so incredibly resource-hungry that, for it to grow, it has to take bigger and bigger slices of a finite pie away from everyone and everything else.
And this leaves us with one final and maybe pretty unsettling question. The AI future is definitely coming, but it's being built with the finite resources of our present. As this new extractive era picks up speed, what's going to be the real cost for all the other technology that we rely on every single day?